Hello, everyone. I'm Donya Mladenovic from MDPI, and I will be your host for today. Welcome to the webinar Smart and Sustainable Built Environment, organized by MDPI and the Journal of Buildings. Before introducing the MDPI journal and the lineup of today's events, I would like to remind everyone that this webinar is being recorded, and the recording will be made available as soon as possible on the webinar webpage. Please note that you need to be logged in to the site forum in order to see recordings. For the beginning, let me introduce you with the MDPI. MDPI is a pioneer in scholarly open access publishing, and it has supported academic communities since 1996. It's based in Basel, Switzerland. MDPI has mission to foster open scientific exchange in all forms across all disciplines. Our 474 diverse and open access journals, including 465 peer-reviewed journals and 9 conferences journals, are supported by more than 295,000 academics as experts who share our mission, values, and commitment to providing high-quality service for our authors. As I already mentioned, this webinar is organized by the Journal of Buildings. Buildings is an international peer-reviewed open access journal on building science, building engineering, and architecture published semi-monthly online by MDPI. The International Council for Research and Innovation in Building and Construction is affiliated with the buildings, and their members receive a discount on the article processing charges. So today there will be 3 presentations of 20 minutes each. Our speakers are Dr. Rashid Makbul, Dr. Rui Yin, and Professor Dr. Rita Yiman Lee. Once they're finished with the presentation, there will be a Q&A session moderated by webinar's chair, Professor Dr. Rita Yiman Lee. If you have any questions, okay, just a second. If you have any questions for the speakers, please feel free to post them at any time in the Q&A box. You can find it in the Zoom menu bar at the bottom of your screen. It would be great if you could use Q&A option and not the chat panel for the questions to the speakers. And for today's webinar, the chair is Professor Dr. Rita Yiman Lee. Graduated from HQU, Professor Dr. Rita Yiman Lee now serves as a full professor in the Department of Economics and Finance at Hong Kong Shuyan University. She is the founder and director of the Sustainable Real Estate Research Center. Her major fields of research interests lie in SDGs, construction safety and health, housing economics, then real estate economics, and applied AI. She is listed as Stanford University World's top 2% of scientists across 22 scientific fields and 176 subfields of all scientists with the highest rank in the field of artificial intelligence, information and communication technologies, environmental sciences, and energy. Professor Rita acts as a journal editorial board member and special issue editor for SSCI and SCIE journals, and is an author of 9 books and over 200 articles over the past 8 years. She has a quite extensive academic network with research collaborations from Australia, the UK, Italy, the USA, Cyprus, France, Canada, Thailand, Malaysia, Turkey, Bangladesh, Saudi Arabia, and mainland China, among others. She is also an uninvited keynote speaker for over 30 conferences. Over the years, she has won many local and international awards as well. She also acts as a PI and co-I for many academic research grants, including high competitive grants from the Research Grant Council and Public Policy Research Grant in Hong Kong, ARC Linkage Grant in Australia, Ministry of Science and Higher Education of the Republic of Kazakhstan, and other grants obtained from quasi-public institutions and government departments. Many of these are related to the artificial intelligence too. She holds a few visiting positions at overseas universities and also gave guest lectures for University Tunku Abdul Rahman in Malaysia and University in Germany. Besides, she previously served as a PhD thesis external examiner for Queensland University of Technology, University of Macau, University of Putra, Malaysia, and others. That would be all from me. Professor Yiman Li, thank you so much for chairing this webinar. I'm holding the floor to you. Enjoy, everyone.
The webinar will start from this first speaker.
Yes, we can start.
So mine should be the last one, right?
Yes. Professor Makbul should be the first one.
Yeah. So we can start with the first speaker. So will you also introduce him or I introduce him?
You can introduce him.
Okay. So hold on a second. So the first speaker is Dr. Rashid, and then he actually surrounds around the sustainable construction and development projects. By doing so, he tries to cover some of the interdisciplinary, cross-disciplinary, multidisciplinary angles of like engineering and also management science subjects, the support of the innovative technologies such as BIM, digital twinning, AI, etc. Key development theories are, for example, those like innovative diffusion, UTA, UT, etc., to propose the sustainable development solutions. His recent key research best include like green growth skills by the North of Thai Combined Authority, worth around 700,000 pounds, and the British Council UK Japan Research Collaboration Grant worth around 79,000 around 80,000 pounds, and also the findings of his ongoing and also completed research project has been published and accepted in many key journals, such as Sustainable Development, Journal of Clean Pollution, Project Management Journal, etc. Besides, he has successfully delivered various research tasks at multiple conferences, symposiums, and universities. He has more than 12 years of teaching and research experience in the top-ranked university of the world, and it's worth mentioning that he has been the top 2% of scientists of enabling field and strategic technologies according to the ranking conducted by Stanford University in the USA. So welcome, Dr. Rashid. So you can start your presentation.
So thank you for attending, all of you guys. I'm going to give a little bit speak on the topic about circular economy and its implication towards fit-out construction projects. So this is a project which we won back in 23 with our internal call at university. And through this project, we try to figure out fit-out construction projects and their waste creation hierarchy and how to control that kind of stuff. So initially, we need to understand what is building fit out. So with that, we can try to understand the buildings, which basically, when we talk about buildings, building industry always stripped out to every few years, which definitely change complete new package of material which can be difficult to reclaim for reuse. And there are some stats. For example, we can say, being in the UK construction industry, we can understand 60% of the material. It is what basically this construction industry takes into overall working operations. The same, what we can talk about is emissions point of view. It leads to 11% of emissions while its operations, and 40% basically overall building hierarchy. So these are a lot of figures which we can say, being in construction industry, need to be worried about. So similarly, the last figure, what we can say, the 30% of all waste produced can be attributed by construction activities, whereas and demolition activities, where 30% waste comes from other excavation activities. So a lot of waste and emission related activities are always there in the construction industry. Okay, so going toward the building fit out, which is one element of overall construction industry. So it is the most recurrent, what we can say, the operations of different activities which goes on alongside the building life cycle. A normal size of building, when it is designed for the 50 to 60 years long period. And whereas like during that period of time, normally a lot of internal design changes happen. Different researchers says differently. Some experts claim like it moves from 15 to 20 times each buildings have during their life cycle have a changes. So which comes each 3 to 10 years time period. This all operations takes about 20 to 30% of embedded carbon, which is about 190 kg of carbon emissions, 77 kg of waste production per square meter. Then this is what basically what we can say. There are a lot of figures which is quite drastic to think carefully about. So during the construction of building, the emissions and the number of construction waste is not much as comparing to the operational stage, which lead a lot of important questions to be addressed. Okay, going further, if we talk about what is construction fit out, we can easily understand there are two categories. This is what for those who don't know what is fit out construction. One is a Cat A, the other one is a Cat B. The Cat A is a basic package, which we normally call it tenancy kind of fit out. The site is ready and the tenants can move over there and they can design and they can bring their own surface and material to use for. And the country Cat B is a more operational kind of package of fit out, which is comprehensive, where design, surface, furniture, everything need to be replaced within the fit out construction. So these are the two important categories we need to keep in mind. Going further, there are four further classifications on this part. One is a shell and core, which is a very basic version, which we need to understand. The building is ready from the outer layer, it's the skin and the structure is quite complete, but inside it is not complete. It is not ready to move yet. It is a very basic version of the category of fit out. When we talk about Cat A, I have just given my thoughts on it, and Cat B as well. Cat A plus is somewhere in between Cat A and Cat B, where surface is ready and partial refurbishment is required for moving towards a high level, where tenants need to upgrade it as per their own design, so they can make their changes to design and then they can fit alongside. So these are the four important operations where most of the wastages are produced, and these lead towards a lot of landfill and operational issues for the stakeholders. Going next stage is about some stats which comes alongside a recent certification systems, which is quite prevalent in the recent years. So if we can understand over here, the major figures throughout this process of fit out coming from the building fit out, causing 28% of emission and a lot of emissions. And whereas we talk about the building material, outer layer and structure, that is merely just 11% comparing to that bigger figures, operational stages, and then comes. So if we go to the left-hand figure, we can understand there are, which are further divided into three parts. One is operational carbon, which is 50% of the total. Then comes a 25% portion of imported carbon of interior material, interior furniture, interior design related operations. The last, but not least, which is a core and shell, which is overall structure and external design of the project, which leads to only 25%. So these figures clearly highlights like how much operations activities of fit out lead towards a lot of emissions and waste production, and which lead towards landfill and overall a lot of cost building for the stakeholders. Okay, the last slides on the figures. We can understand over here the core and shell, which is the least waste and the emission production stage. Then going further to interior stage, which is about having a time span of 8.5 years, and the last 2 years, 2.5 years life cycle. So here the important stats we need to understand: when a tenant or tenant party move towards any non-residential building, within 8.5 years, they cause about the waste production, which is somewhere equal to core and shell. But in some worst scenarios, it can lead towards 4 times more than the external structures waste production and emission control, which maybe can lead to a lot of landfill and cost problems. When we talk about the building stock of fit-out constructions, we can easily understand in European regions the important figures which are here are, these are retail and offices, almost equal to 27%, both of these. So these are the biggest stakeholders, the biggest projects which need to be carefully understand, and where different actions need to be placed for covering fit-out circular policies and practices. Whereas if we go with the figure 4, we can understand over here building sharing model, where building fit out within the 60 years life period, we can understand the different layers, different operation, different structural and internal design related changes lead towards a lot of waste and moving towards a different. For example, stuff inside this stuff can lead from 0 to 5 years. Mostly experts say here the figure is somewhere between 3.5 years, but maybe sometime it is a 5 years period time now. Space takes 5 to 7 years, services take to 15 to 30 years, and then comes structure, skin and site, which is not normally required, but it is a bit longer. So these are the figures for the 60 years time period, which are very much enormous in terms of managing waste. So one thing we need to understand over here, building industry, more specifically fit out industry, work on the 3 points at the moment. One, take, make and dispose. Nothing anything serious about reuse and recycle and refuse processes. So these take, make and dispose categories are, we can say, very much clearly understandable in the 9R framework, where the propensity of linear economy towards circular economy is not much visible so far, although a lot of activities happening across the world. But in the UK situation, this is not done clearly. So here we can understand the circular economy major principles of refuse, reuse and recycle. These 3 concepts, which are further divided into 9 R's models, are not implemented. But in order to get a better fit out environment and dynamics, these refuse, keep products and materials in use, reuse, regenerate natural systems, and recycle, design out waste pollution need to be implemented in a better way to get a better picture of fit out. Going further, we have a clearly landfill tax raised like in recent years, and this can lead to like a dumping process like more smooth with the heavy tasks. Basically we can go to figures, although it's all dated, but we can understand the each year's timeline reducing waste dumping activities. So with the increase of landfill tax, these landfill activities are happening less and less more. So it is going towards more circular side, but not completely what we can say the complete circular package, but still there is a linear activities happening. Beside, if we can talk about our research impression over here, we also take an idea from the UK Construction 2050 strategy. We have different set goals at the moment. The first of and most important goal to cut down 80% emissions by 2050. And it can hopefully also lead towards waste reduction and recovery. This is what the construction industry UK is aiming for future. And the important element in this way is a landfill, and beside other activities, hopefully with the modern technologies it can be supported with. Then going further, we can say this is very much clearly at the moment, as I talked about take, make, and dispose idea. This is what so far implemented and prevalent in construction industry. And again, the nature of material basically, which make the material not to reuse so far, because the material as produced, it can be implemented but not reused somewhere later on purposes. At the same side, if we talk about building certification systems, environmental certifications, they have no clear rating systems at place, not openly available for the stakeholders, which can enforce these parties to implement these circular processes. So considering these elements, it is important to consider towards circularity in the construction of building fit out packages whenever there are any non-residential buildings are there to use for, which are mostly for operational office and real estate purposes. So these need to be considered towards circularity point of view. So considering this one, if we talk about modern technology, one important point come into our attention, which is a BIM. BIM have important benefits. For example, it can help understanding accurate cost estimation, which can reduce the unplanned costs and enhanced cost control. Then it can help reducing time, mistake, efforts throughout the life cycle, which is quite understandable thing. The other thing, it can help designers to understand real-time decision support data, which can lead towards sustainable objectives inside fit-out construction. This is what we observed recently. And another benefit we can say is the 3D modular visualization. It can lead towards better results for the coordination, analyzing, and visualization of the easier handling of material. And then if we talk about facilities management, which is important element of fit-out construction, it can lead towards a lower and long-term expenses. That is what we can avoid with that point. And lastly, what we can say, the clash detection and coordination between different stakeholders and proper documentation and design collaboration. So these benefits can help out to fit out, reducing time, cost, and emissions. So these are the important points what we can see. So we have also in this project had a quick overview of all the available assessment tools. These certification systems, for example, SKA, BREEAM, and LEED. And we could understand, although these certification systems can provide somehow few guidelines on the fit-out construction, but these are not much clear. At the same time, the cost is a big issue to implement these throughout the process, and their handling things whenever they come to consultancy activities is difficult to implement. So that is basically the bigger problem at the moment in terms of the implication of this problem. There comes a new work packages alongside recently. For example, RESET standard, which is a data-driven standard. It helps with the support of data management, organizing, and controlling of activities, which is most popular at the moment, and it helps understanding about the life cycle of the throughout the fit-out construction. So this software can be readily available, freely available for the parties, and it works mostly on the three important components of embodied carbon. And this embodied carbon works throughout the building material sourcing, transportation, and construction activities. Then comes the RESET embodied circularity, which works on the two important elements. One is a source of life and end of life, the overall product of the circular fit-out construction activities. The last but not least, which is more about chemical ingredients and chemical of grassing of like the material inside the activities. So this is how we can get a good benefit of these kind of packages, which are quite good, provide visual pictures of the material and can help understanding better packages. So beside, we had a clear idea of circular economy activities in the construction industry. With the time limitation, I'm just quickly going through. So because of this, since these activities were part of project, so I thought maybe we can highlight. Okay, after going through complete and comprehensive literature and going through pertinent theories, for example, system theory to understand our different important factors, resource-based views, intervention theory for the landfill hindrance impacts, and diffusion innovation. So we developed our initial framework to test in this research. This is what we covered in our project, and try to understand these elements or how these can lead towards circular building fit out construction. So we use a triangulation of methodology using quantitative and qualitative views, where basically we use surveys, interviews, and then matrix surveys in our methodology. In initial surveys, we used 272 experts inside construction industry, having different trades, mostly senior people, and having a lot of experience, years of experience. We got their views to understand what are their thoughts in terms of fit out construction views. We used definitely developed skills, and the details are here. Initially, we try to understand the linkage between different factors. We can understand over here all the factors have a significant impact on each other: waste management, building fit out construction, landfill cost, which clearly understand what industry thinks as the literature says. So nothing difference between our findings and literature thoughts. There is a small difference, what we observed, which was not covered previously as highlighted. Landfill cost, it is hindering impact. It is basically putting significant impact between waste management activities and landfill circular fit out construction, whereas it is not putting any impact in between other factors like environmental assessment and building information modeling. So there comes, we can see the moderation impact of landfill cost is very much important whenever different stakeholders think about waste management activities in the towards construction landfill operations. Then at the second stage, we use a matrix structure, matrix of collecting data, and then through interviews as well. So we adopted this package to understand these 6 important points: fit out construction, waste management, environmental assessment method, building information modeling, landfill disposal cost, and circular economy, to understand what are the thoughts of different experts on these points. We got 2 important ideas over here. Industry thinks about on 2 points: fit out considered to be most important to them, whereas environmental assessment and landfill, they believe these are most impactful factors according to their understanding, comparing to the circular economy, waste management, and building information modeling. So technological element is not much carefully considered by industry. When we compare our final model to initial model, it was very carefully understood. Building information modeling over here, as per the final check, understood as a central figure rather than initial input. So environmental assessment and waste management considered to be the most important, leading towards circular building fit out construction, whereas a landfill as a supporting figure, and then comes a building fit out as a secondary supporting factor, not comparing to the like as initially literature says. So there comes a small difference between our findings and the earlier available research on this topic. Going further towards interview, we used 4 experts' views over here. Their profiles were having more towards sustainability and construction project management. So we can see they were quite experienced in their fields, and it was very good to have their detailed view on the topic. And when we go through their findings of transcripts, we could understand the central point for each of the experts were more related to waste landfill and construction, building recycling, reuse, and whereas we can see the technological element is not much covered in their idea. Sustainability is there as a secondary thought, but BIM and other ideas are not much covered in detail. The same goes with the here tree map diagram. Waste management and landfill, the most important element. The reason is mostly these experts talk about the economical element, more about the costs for the construction points. Going for the interviews question, what we asked to the people, the important thing what we can say, we asked about the embodied carbon element initially. And then we talked about the innovative waste management practices available, economic element, integrated BIM, and environmental assessment, and finally circular economy. So we try to cover almost every element which is normally taken carefully in the construction literature related to fit out at the moment. Over here, we got a justification of each of these, their summary. We can understand mostly people talk about the hidden packages of fit out, which they talk about, which is not seen mostly. Mean circularity element is not mostly covered. Stakeholders take that waste and they just go towards landfill, try to use and minimize of its implications. So rather than using, try to avoid taxes as much. That is most point carefully they talked about. But on the other element, they are not still clear over here why the BIM implications are not properly used so far. Finally, we go with the final thoughts on this work, what we did in this project. We could understand over here 4 important elements which lead towards a 5th important building fit out. It is what properly acceptable, whereas the technological element is not considered. Landfill is considered heavily significant by construction industry to be carefully considered whenever applying strategies, whereas circular economy principles need to be carefully think about at the early stages of design, where basically stakeholders can carefully understand how later purposes these activities can be changes afterward. And similarly, these activities can lead towards better disposal cost afterward. So we generated a few publications out of it, which are readily available, and readers can go and have a quick overview, as the time is limited, and I believe my time is over, so I can stop sharing my slide. Thank you. That's all.
So thank you very much for your very excellent presentation. So not sure if there's any questions from the audience. So if you have got questions, then you can actually just open your mic and then ask the question.
We can first do all presentation, and after that we will have Q&A session. So
we have got a question that says, do buildings really get disposed after 60 years? Do we know what percentage gets disposed after 60 years?
Sorry. Thank you very much for the question, Gabriel. Basically, the 60 years period of time is not more about a dispose, it is more about a design of the building, which basically planned for 60 years. And we don't have any specific over here, but it is considered like after 60 years, design is almost 80 to 100%. Basically, overall external design is also replaced with that. So I hope it has answered your question.
Okay, so now I would like to see as if there is any question from the floor, from the audience. So any questions from that? So basically, so thank you very much for your presentation. So if no more questions, then we will go on to the next presenter. Oh, we still have got if you have any questions for our speakers, please post them in Q&A. Yeah, still that you can post it in the Q&A box.
Yeah.
Yeah, thank you very much. So we'll go on with like Dr. Jean. So
Okay.
Thank you very much for watching, and then let's welcome the next speaker. So the next speaker will be Dr. Jean. So let me get back his introduction. So while Dr. Jean is like putting his PowerPoints online, and then I will just get back to Dr. Jean's introduction. Dr. Jean actually has an established track record on recycled aggregate concrete, circular economy practices in construction and destruction waste management, and developing Industry 4.0, 5.0 featured industrial digital technologies for the construction and demolition waste reuse. And in these research areas, Dr. Jean has actually offered over 90 peer-reviewed journal articles, over 6,600 citations received, and then 2 book chapters, editing 1 book, and 1 patent innovation in using construction waste as sustainable construction materials, and title Recycle Waste Material Applied in the Prefabricated Enclosure System for Construction Sites. And currently, Jean is implementing the research of integrating circular economy, C&D, waste violation, and in digital transformation. SPI or Kauai PI, Jean has secured over £500,000 in the areas of circularity and also decarbonization for various external schemes, including Innovative UK, British Council, and Royal Society, etc. So welcome, Dr. Jean. So could you please share your presentation with us? Thank you very much.
Good morning, afternoon, depending where you are, everybody. And thank you for the introduction to Professor Rita Lee. Can I check if you can see my screen? I believe it's already been shared. Yeah.
Yeah, we can see the screen.
Okay, great. So yeah, my name is Roy, and again, thank you very much for being here today for me to share this title, the AI and digitalization for circular economy practices. I actually started my academic career in construction management, more in the waste management and material valorization. And the AI and the digitalization for me, it's more like a methodology, a platform. But forgive me if you have different opinions, that's totally fine, because some people may treat the AI and digitalization as a subject, but to me, it's more like a methodology or a platform. And in my presentation, the subject is actually the waste valorization from construction and deconstruction. And that is my view. Maybe after a few years, we will be adopting more and more BEAM or digitalization or AI. But the subject itself, in terms of circular economy and the waste valorization, will carry on maybe with some different methodologies in the next few years. Okay, so just a little bit about myself. Again, that is a subject myself, the construction and demolition waste valorization, which has been with me for the past decade of my career so far. And I actually started my career in China, which I will introduce a little bit in the next few slides. But that's where I am located right now, and where I am presenting my work in southern England. And here is a quite well-known waste house. It's claimed to be 99% from all kinds of different waste materials. It's called Brighton Waste House in southern England. That's a map. So it's an award-winning, created quite a good social impact from a colleague in architecture in southern England. And get into the waste house, you can see all kinds of slogans apart from the reclaimed materials. You can see the wood, the plastics, even some urban solid wastes from the daily life. For example, the toothbrush, okay, for example, the duvet, okay, they have been all adopted as reused materials to build this waste house. And you can see these slogans, eco-build, all kinds of slogans. Like in the UK, we generate around 120 million tons of wastes. And in the construction, demolition, and excavation, you can find the data from the UK government. Up to 60% of the waste could come from the construction, demolition, and excavation in the UK. Although we have achieved over 90% of reuse or recycle, but in terms of the circular economy hierarchy, which was presented by my colleague, Dr. Rashid, the former presenter, we have up to nine different levels in the circular economy hierarchy. So we have achieved the 90%, but a lot of them still in the down cycle, just to barely avoid being landfilled into the urban landfill. There's still lots of potential. We can achieve higher level of upcycling in the circular economy hierarchy. So lots kind of slogans or the philosophy, if I can call it, in this waste house. There really isn't such a thing called rubbish or trash. It's just the resource that has not been put in the right place. Okay, it's just a philosophy of the waste management professionals. And this is in this slogan, okay, it's actually we used to like half serious, half joking when speaking between the academic and the industry in England. What is it we said is every 5 houses we built in the UK, 1 house of material wasted. So it's very inaccurate estimate of 20% waste rate. Okay, 5 houses built, 1 house wasted. Okay, we've been half serious, half joking. Okay, and starting from my career, when I started as the academic career as a early career researcher, that was one of my publications back in 2017 from the field trip site investigation and the stakeholder investigation back in 2017. That is a table from from multiple different secondary sources by mapping between the different countries or regions, between the Japan, some are more developed regions, including the China, in terms of the construction and demolition waste recovery rate. So you can see, actually, I often look at some other countries as available secondary data from the published sources, like, for example, the Japan's waste recovery and how they form their own market-driven waste recycle and reuse approach, as compared to some other countries like top-down from their policy-driven or conformance-driven approach to enforce or to provide incentive for the waste valorization. And that is a field trip that I took the photos from the site, and by speaking to the manufacturer, the business owners, okay, a small SME or family business in China. That is their business model. Okay, we had in the eastern coast of China, they have quite a lot of demolished buildings, maybe only 30 years. And the debris from the demolished buildings, like in many parts of the world, it's often mixed with red bricks, concrete, maybe some other plastics, glasses, or all kinds of wastes. It's always difficult to segregate the wastes. So that is actually one of the worldwide issues. I don't think we even have the well-developed technology today to separate the different wastes from the beginning stage of demolition. So often we kind of mix everything, okay? Because it itself is very energy intensive and labor intensive to separate all the wastes. So basically what we have been doing, even here in the UK, is we just crush everything and to make into the smaller pieces, or we filter or we wash, and we make the recyclable or the reusable aggregates for being reused in the recycled products, like the bricks or some other masonry blocks. And of course, we have to meet the national standard and make into the final products. So this business model or this production line get the dumped waste from the dumper. So this manufacturer, this business charge them for dumping their wastes. But on the other hand, they make the product and sell back to the market. So they charge the customers. So they kind of charge the source and charge the final product, kind of like a business model, right? And that's a small business. And you can see more photos that I took from the crushed sources into the final solid bricks or hollowed bricks, from the source to treatment into the final products in this business model and in this production line. So some background, since afterwards in 2017, I moved from China to the UK, okay? And here are some background. So we're talking about the decarbonization everywhere, like in the UK. Also, as some background information has been provided by Dr. Rashik, and every cement, okay, cement is widely used but very energy intensive, a huge embodied carbon in the manufacturing process of the cement. Statistically, each kilogram or each ton of the cement we produced, nearly up to one same amount of carbon dioxide is emitted. Nearly it's 1-to-1, okay, per unit of cement manufactured. Nearly the same amount of carbon dioxide has been released to the nature. And cement itself can contribute up to 7 or 8% of all the carbon emissions crossing all the industries. So it's a huge influence building material. And for this reason, you can see numerous work in industry, in academic research, laboratory work, lots of work talking about or sharing the latest results on decarbonized cement or replacement for the cement. Okay. So see, here are some of the development needs. How we can reduce the cement. Reducing the cement itself is to reduce the carbon. It's a huge impact on overall the carbon emission to the environment. On the other hand, is how we reuse or to increase the upcycle level of the demolished construction and demolition waste from downcycle towards higher level of upcycle according to the circular economy. The last one is what I said. I think it's a methodology for adopting any BIM or any 3D printing or digital manufacturing or AI or blockchain. There's a lot of work in this area. But to me, it's more like a methodology that is to adopt the digital transformation and AI for the purpose of valorizing the wastes. So that's why I said to me it's a tool, it's a technology, it's a platform, it's a methodology. But the subject itself is a waste valorization in all my presentations. And we can find across England, we can find some of the quite a few family businesses on adopting all the bricks or blocks meeting the national standard. That is a national standard of the blocks in the UK. It adopts 100% all from the recycled aggregates from the locally demolished buildings or construction demolition waste. It's all available in their business website. 75% or 100%, okay, and recycled aggregates. We also collected some of the waste to our laboratories. And apart from the cementitious materials, another type of material, timber or the steel, okay, these are also widely used construction materials worldwide. So that is a circular economy, a loop, a circular economy cycle, whether we can reclaim the existing steel for reconstruction in the structural design. And this enterprise, EMI, claim to save up to 97.5% of carbon by reusing the steel. But of course, not all the steel can be reused. Some may be rejected for other purposes in a lower level of circular use. And some can be converted into the reusable steel. And we have the colleagues who actually develop also in the BIM platform for the reused steels, that the BIM plugin has been adopted by the industry partner on the digital platform for structural engineering to design with reclaimed steel. Okay, that is another latest practice. So again, the AI or digital transformation, it's been a really emerging area in the recent years. It also been applied to the construction and demolition waste, including some other universities, how we adopt the AI technology to detect any structural risk due to the older structures. Okay. And some of the latest peer-reviewed papers talking about what are the current gaps in adopting AI for construction demolition, starting from the early stage waste sorting, detection of the different type of the wastes. So that has been always a global challenge of how we detect, classify, and separate the wastes from the demolished debris. And you can find lots of existing studies from the literature review. Okay, and in the past decade, you can also find a lot of studies of how to adopt BIM. And now we are talking about from BIM to digital twinning, from BIM to blockchain, or from BIM to AI, or integrate BIM with AI and the latest digital technologies for construction demolition waste valorization, starting from the early stage building design, for example, to estimate the waste generation or to detect the different type of the wastes, or even we can see some of the work studying adopting the VR, okay, to simulate the end of service life of the building, to simulate the best way to deconstruct rather than demolition. As we can see, the demolition is also the baseline to totally demolish the building, but there are some other partial demolition, okay, or the refurbishment or repair or fit out construction, as Dr. Rashid has been focused on the different ways. And what is the optimal way? So certainly there's a lot of work going on. And so I propose some of the methodological framework by integrating the digital AI data analytics into the circular economy for waste valorization, especially for the end of service life of the buildings. And these are some of my architecture of the circular economy platform in some of my recent proposals. And specifically, I divided from the waste source. So one is a source, the other is a final product. In between, there is a treatment methods, how you treat it according to the different levels of circular economy that can come up with a different type of the products. So it's from process to the product. A lot of work we still need to carry on. And in terms of my vision in circular economy, the digital circular economy hub, and I'll be presenting some of the papers in some are based on the international mapping between the Vietnam and because I have quite some connection in the recent years with Southeastern Asian countries like Vietnam, Thailand, and extending to other ASEAN countries of their national strategy of circular economy in waste valorization. And so these are some of the field trips last year, like adopting the waste materials for 3D printing concrete into their office. And that is a partner in the Thailand construction and concrete industry. So, and just for the time being, I'm moving towards the end of my presentation. That is a vision of the digital circular economy hub. We have a lot of work to do. I call it 3D, okay, so digital data and design for deconstruction, which is a core part for circular economy. And under the 3D or digital circular economy hub, we have quite a big team in the UK working on the different areas, including the knowledge sharing, research innovations from source to treatment into products of adopting the circular economy, education and training with local stakeholders, policy standardization is a longer term social, economic, and environmental impacts. In the same time, we have secured some of the fundings to attract the early career researchers. We have recent years at my current institution, I have secured some research fellows working in the area of construction waste management and in multiple dimensions. Some of them are focused on the material structural engineering for testing and evaluating the products by adopting waste sources. Some are coming from the social science background in an interdisciplinary perspective. Some are more in the environmental science. Some are more in the social science or in the structural civil engineering background. So we are still looking for some British Council research fellows coming to the UK. And we are also seeking candidates to apply for the European Union postdoctoral fellows. And we have some track record in networking grants for mutual visits in short-term visits between the UK and the rest of the countries, and more to come. So if you're interested in pursuing a short-term or a fixed postdoctoral position, you are welcome to contact me. That is my email address. And that's my presentation for today. Thank you very much.
Thank you very much, Dr. Jin. So I would like to see as if there's any question from our participants regarding Dr. Jin's presentation. So you can actually just shout or raise your hand. We have got a question that the attendee link is not active. I'm not sure how to. What will be the direction of the social scientists of these projects in the near future? Dr. Jin, there is a question for you.
Okay, so what will be the direction of
social
science? Actually, I will say a lot. The short answer is there's quite a lot. For example, some of my students adopting some of the traditional theories, like the user behavior theory, okay, into the waste management, and especially into the early stage waste sorting, and in the recent years, and also how we drive the multi-stakeholder engagement of circular economy in their products in their construction waste management, from quite a few from recent years, MSc students or PhD students or external examinations. So you have quite different social science theories, like the social cognitive psychology or user behavior. I'm not expert in these areas, but because of the students are really active, they kind of bring other theories into their research of the driving the circular economy for waste management. So that actually extend my horizon. I also learn quite a lot from the supervisees of my students. So in short term, in the short answer is quite a lot. Okay, traditional theories and the stakeholder engagement, and also in practice, the local stakeholder or international stakeholder workshop disseminations and driving towards the policy, and or simply a review of the existing standards of adopting waste products into the product design or into the concrete design. Okay, there are quite a lot from the social scientists. I will say simply doing the engineering or the science or the material is not enough. We certainly need the social scientists in the circular economy, which itself is an interdisciplinary subject.
Okay. So thank you very much. Do we have any other question from the participants? Do you consider relationship between cost, recyclability, and its effects on housing market as observed from ecological modernization theory? What are your
Thank
thoughts
you.
about this? I myself do not know what actually is like ecological modernization theory. I'm not sure if all of you know that.
I have to be very honest. That's also my learning curve to know the different theories. First, I don't know this ecological modernization theory. You can actually enrich my, my horizon of the social scientists' theories. But in terms of the cost recyclability and its effect on housing markets, it sounds like a really interesting area or topic for investigation. So my thoughts are it's good to think about a theory into a contemporary topic, because cost or recyclability or the effects on the products or the housing, if we consider house is also a product itself, is a lot to investigate. Of course, you may want to consider the cultural background, the geographical background of where you are based. So it's always a multidimensional study or multidimensional analysis. And you could even consider combining the methodology from Dr. Rashid. There's up to 6 different dimensions to evaluate, okay, cost, recyclability, environmental or social, okay, or engineering properties of the products. So these are some of my thoughts, but I can talk a lot more. You have my contact. And yeah, thank you for another comment for leading the SDG project. And yeah, that's my contact, you know it.
Okay, so thank you very much for your presentation. So mine will be the last one.
Okay, I now stop sharing.
So you guys can actually have got a bit much more discussion afterwards, like what exactly are these like theories contribution to like to our like academia, how that we can be applied, etc. So that I will go on with my last presentation. So actually this presentation the original point is actually lies in like Buildings Journal. And then so this is just a bit the introduction about the impact factor 3.1 now, and so as a side score, which is like 4.4. And then a bit about myself. So today I'm talk about like the analyzing worldwide wetland parks research, spectral cluster algorithm lattice semantic index approach. So I am Professor Rita E. Manley. So currently I am the professor in Hong Kong Chiang University at Department of Economics and Finance, and as a director of the Sustainable Real Estate Research Center, and in the same university. So this is my Google Scholar page. So I actually welcome all kind of like collaboration. No matter is like funding, which is like very important now, and then paper. And then so as like maybe if you have got some of you that you know who want to like further study I also welcome you to come to our university for further study, no matter it's a master or like MPhil or like PhD level. So I recent 4 years I'm the top 2%. Just like what she has is a top 2% of the scholar. So I'm also top 2% in like under Stanford University research for the recent 4 years. So my research area: real estate economics, construction safety and health, applied AI, carbon emission, and also sustainable development goals. So a bit the introduction about like what I wish to talk about today about the wetland. The wetland is actually a special ecosystem which is called the wetland system, and then plays a very important role in maintaining the worldwide ecosystem balance, mitigating climate change, enhancing global environmental and ecological sustainability, promoting human well-being, economic development, and also cultural heritage. So wetlands only accounts for about like 6% of the surface area of the earth. 40% of the plant and also animal species live orbit over them. Consequently, wetland systems are critical in maintaining biodiversity in the world. They also play some of the recent role in like water management, ecological water storage and supply, and also like flood control and water purification. So the constructed wetlands are actually ideal for addressing water circulation issues, and small and dispersed urban wetlands contribute significantly to the carbon storage. Furthermore, wetlands are valuable to humans for producing food and also high quality raw materials for industrial and also agricultural production. Moreover, the wetlands have the potential to produce aquatic products, fruits, and also vegetable products, and then green food. So consequently, they can be developed into the agricultural production regions and also like resulting in economic benefits. Additionally, they can foster like ecotourism, boosting their local economies. So although the wetlands have provide like numerous benefits, they are frequently threatened by human activities such as like drainage, construction, pollution, overfishing, resource overexploration, and the reproduction and the introduction of the invasive species and the impacts of the climate change. So they are natural or artificially formed parks and that combine like wetland ecological functions and typical park features, achieving the goals of the environmental protection, science education, leisure, and recreation, etc. So since the wetland park actually produces a certain proportion of the wetland area, it has important functions in conserving water resources, purifying water, storing floods, and controlling flooding control, droughts, regulating the regional climates, and also increasing the biodiversity. So wetland parks actually features a combination of the resource protection and also the rational the utilization of wetland ecosystem, which includes the safeguarding and also using the key resources, including like the biological stuff, such as like wild animals and also plants resources and cultural resources. So for the research, we actually try to use a systematic analysis of the wetland park research in the past, so that we try to utilize the data from like WOS, the Web of Science, and also Scopus with the terms like wetland and also park. So we only like test on those like English article and published between 1996 to 2023. So we actually have got the preliminary screening and secondary screening and also scientometric analysis of them. Eventually, we have only got like 591 after the screening process. So you can see that actually we have got more and more research over the years. And then in 2022, for example, it has got like 80 papers. And then if you try to look at the major research areas, you will find that some of the interesting parts which includes like China, you can see that wetland parks in itself, probably they have got a lot of their research to come from the China. And so South Africa, so that they have got a lot much more research as compared to like other places. And then many of these are actually mentioned about like biodiversity stuff, the ecology, and also like some others elements as well. So for the keyword centrality, it actually the higher the centrality of the node, the greater its influence over the overall network. So the nodes with a centrality of like greater than or more than or equals to the 0.1 are referred to as like critical nodes. So if you try to look here, we have got like the as what we have seen in the keyword clustering, you see that there are a lot more like location stuff related to China, also South Africa. So that you can see that actually they are also on the like top number with a lot of like frequency that is like mentioned as well, and so as like biodiversity. So that the research the interest in that's the first published, which is like 2003 for China and the 2001 for South Africa, and biodiversity in 2005. So for the So for the top 25 keywords, Scientific words are actually refers to the active or emerging research areas. So that you will see the community structure is sort of the earliest scientific words. So that it is like the earliest active elements, but it is no longer active now. You can see that actually the red lines stop somewhere in 2011. And then the red line is actually represent the specific diacritic stage when the keyword become a hot topic in academic research, and the light blue line shows a note that has not been appeared. The dark blue line shows a note that has begun to appear. So for others, like say for example South Africa, so you can see it's like 2001 to 2015, and so it's like Asia 2005 to 2009, and then Eurasia 2005 to 2009 as well. So you see that however compared to like many other like bibliometrics research, most likely they would just say like US like the top one, they have a lot of publication. But then for the wetland parks, it seems that it is we have got a lot of the publications come from like South Africa, Asia, Eurasia, and then Africa as well. So not really that there's like where they come from like developed world where there is like better, suppose there is like better economy, so they have got like more funding, more research, but then it's like this in this area is not the same. So the spectral cluster results, so that you can see that the top 10 cluster include like South Africa, Pyramis, Australis, Zhejiang, and then ecosystem environmental monitoring, China, etc. So for these top terms, so we have got like other species, which includes like soft white grasses, soft lake coral reef, and then the leaf thickness. So we have got like leaf traits, soil salinity, etc. So these are some of the examples of the abstract terms. So that the works they usually appears in the abstract. So for the collaboration, you will see that there are a lot of collaboration between like China and also South Africa in this area, and so as like United Kingdom. So other places will be like, hey, I've got less collaboration, but still that is like popular one, which you could say like for example Germany, which is like the world is bigger, Germany, Australia, that part of places. So this you can see that actually the who where is the king of the research of this area. So the top 15 latest countries that regions that they have got the wetland park research. So if you look at here, the latest countries or regions that engage in the wetland parks research, we have got Malaysia, which is like 2022, which is a very, very recent days that they have engaged in it. So it's like Germany and also Spain and then Nigeria. So for these places, you will see that actually a lot of them, they are developing countries for which that they eventually enter into the wetland park research. And for those that is like earliest research, you can see that the earliest one that we have got a lot of the majority are developed countries. So as what I said is that well, most likely for the research, actually because of like funding, because of like education purposes or etc., you will see that actually developed countries they have got like a lot of much more funding and resources. And then you will see that actually they have got like earliest research as well. So there is like Canada, for example, 2013, and then India 20. But then we still have got some of the developing one, which includes like India and also South Africa. So we can just say that the places like, for example, China is like, well, they that is not the that is not the earliest or that is not the latest one, but then it has got a very top research. And then for South Africa, for example, they have got a rather long history. Okay, rather long history in that. And then so it means that well, it doesn't really matter when you start doing research on this area, but they eventually some of them they become like very they are very productive in this area, and then they become like more and more productive in this area, and then they are top on the list. So for further investigation on the paper, you can actually go to the paper which was originally published in Billings Journal, analyzing worldwide wetland parks research spectral cluster algorithm Latin semantic index approach. So you can try to search this paper and then read through the whole paper about like what actually is about. And then to some extent, it actually paves the way as like if you want to do on further research, so what sort of the thing that you can that you may think that well, if I want to do on further research, probably I have to like focus on which area so that it is of like higher originality, etc. So for the presentation, so this will be like the end of my presentation. So for context, you can actually email me ritalcec1@yahoo.com.hk, and then we have got like MPhil and also PhD in economics. So in this area, so if you want to like move on with like sustainability economics or like construction economics or like for example building economics, and so as like those like areas for which that I'm currently working on, like for example those that apply AI into like the sustainability, apply AI into like for example the construction and also like environmental stuff that you can contact me as well. And then these are actually paid position. It means that you will receive like money, you will receive stupid for like if you engage with the 2 years of the MPhil research and also like 4 years of like full of the PhD study. And then so that one is like the university will pay you the stipend for like monthly income. And then for another one that is like another one that is an MSc in fintech management will also be launched in 2026 as well. So if you have got some students or you yourself would like to like further study on a fintech management, you may ask the question is like, why do you think that there is a link with the fintech? Because a lot of circumstances are in like some of the developer how they can like transfer money from one place to another, they will try to use a fintech as well, like blockchain, for example. And then for this one, you can actually also if you want to like further study in fintech management, you can actually also go also study for our new program, because this is like new and which will be launched in 2026 in principle, because eventually you still need like the chief executive to approve it. And then for this one, it is like around $200,000 Hong Kong dollars per year, and then it is only 1 year study. Unless you go on like for example exchange, go to UK for studying for 1 year or so, then that is another story. So I welcome all of you for the collaboration, which includes like paper, as what I said earlier. There's like paper collaboration, which is like all in all, I always welcome like paper collaboration, and so as like other collaborations such as like grants, because I have got like quite large network in like grants, no matter it's Australia or other places of the grants, so it's like possible as well. And so as like maybe a student exchange program or a student like collaboration program, like for example they go on for like further study, that one that is also possible. So thank you very much for listening. And then so if you have got any question, you can ask me now. If you don't have any questions, then we will just end up here. So yeah, if you have got any question, you can put the question into the Q&A section. When we see the in the introduction document, not yet, because we will actually provide the information later on after like the chief executive approval. So but then in principle they should be get approval soon. Yeah. So it's just an introduction. So but then later on we will talk more about that, and because by the time that we have got like officially open for the application. So do you find that in your research, do you find that the wetland habitation is like policy driven or altruistic? According to Greenpeace, South Africa faces great biodiversity loss due to climate change or other pressures, including the decline or the loss of over 1 million plants and animal species due to geographical location. It is most vulnerable to climate change in Africa and respectively the world. I think a lot of the circumstances for the wetland part rehabilitation, it is like policy driven, especially in Asia and also like South Africa, that kind of country, that kind of places. The major reason is that this kind of like wetland park in itself, that you cannot say that it will generate a lot of the economic benefit. So for generation of a lot of the economic benefit, of course, we will have a lot of like business that is like try to do it. But for wetland park, that kind of things is like there is a lot of like that there's a lot of cost involved, because for like running a wetland park, it's not running a garden. There is some kind of like professional requirements, professional knowledge that is required. So that's why that there's like so that I think it is more like policy driven rather than altruistic. Yeah. So we have no more questions. So let's see, one more question. The link for attendance certificate is not working. Hey, our host, can you solve the question of this attendee? The certificate link is not working. Is it possible to help? Okay, so our host is trying to answer this question for that. The link for attendance. So I think the host will be like very much helpful, and then ready to like help our attendees if there is like any sort of like questions on that. One more thing that is like our previous two speaker is about the that he tried to our two previous speakers were all about like construction waste and also like the concrete that sort of things that I have also done a bit as well. So for collaboration wise, so if you are like interested in working on like concrete stuff, I also have got some of the expertise in that area. So we have got so that our host has given the link as well. So that one is for like attendance link. So you can try and see whether or not that link can work. I've seen the link, the certificate. Okay. So anything we would like to say for our host in introducing the journal or whatsoever?
There is one more question in Q&A session part.
One more question in Q&A. Let's see. Which question? Oh, one more question. Do you have any plans for like AR, VR self of the spatial design and SDG? Yes, we always do something like that is related to these kind of stuff, like AR, VR, whatsoever. Yes. But then the question is like we will see whether or not that whether or not that it can work well. We have actually done something before about the VR and also AR. The VR for like the VR for those things that's like the construction safety, however. And also for SDG, of course, because I guess most of us actually know that previous work, the link of the previous work, yes. Do you mean the paper or what? For the link of the previous work? You mean the wetland park or the wetland research or what? VR and AR projects. Yeah, I have got something about the VR. VR projects. Not sure if you have received it because I tried to send it, but not sure if you can receive it. Yeah. So thank you very much for attending this section. So if you have got any question, just email me anytime. Yeah.
Okay, thank you, Professor Yiman Lee, Dr. Makbul, and Dr. Jin for your time and interesting contributions to this topic. I would also like to thank our participants as well. I hope that you find this webinar both interesting and insightful. Please note that certificates of attendance will be available shortly after all registered participants on our SciForum account. If you have any questions related to this webinar, simply send a message with the webinar date and title to journal.webinar@mdpi.com. As a reminder, the recording of the webinar will be made available as soon as possible on the webinar webpage. We would really appreciate if you could take a couple of minutes to complete our satisfaction survey on the following link provided in the chat box. Your feedback is essential for the improving future webinars. Thank you once again, and I wish everyone a nice day, morning, evening, wherever you are in the world. See you. Bye.
See you. Bye bye.